Okay, a couple extra examples just for in case you need them. SHRATEY, simplify, can't do it. You're going to want to cross off those x squareds. You cannot do that. You cannot pick and choose. It has to be through one on the top and one on the bottom, multiplication and division of your factors. That's not that. It does not work. H holes, nothing cancels, so there is none. R roots, we set the numerator equal to 0 because there is nothing adding and subtracting on the outside. And negative x squared equals 0. Divide by negative 1, still 0. Force the square root, still 0. Your root is the origin. That is not weird. That is totally fine. Vertical asymptote. Denominator set equal to 0 and solved. So if I have x squared minus 4 and set it equal to 0, I'm going to, you could factor it for 1, or you could leave it as such, add 4, square root. Either way, make sure you understand that you're going to get plus or minus 2. So you have two vertical asymptotes at positive and negative 2. If you had factored your original equation and simplified it that way, it really isn't simplifying. You could have told me that. You could have told me, let's see, x plus 2, x minus 2. But since nothing cancels out, what's really the point? So there's another reason why your vertical asymptotes are what they are. Your horizontal, Bobo, Botan, or the same. It's the same. The degree of the numerator is 2 and the denominator also 2. The ratio of your coefficients, it's not negative blank over blank, it's negative 1 over 1. So your horizontal asymptote is at negative 1. Let's plot those. Go back. Sorry. Negative 2 and 2 for your vertical asymptotes. Okay. Negative 1 for your horizontal. Sorry if you just heard my phone buzz in the background. Okay. T table, plug it in. I'm going to do this really fast because I don't see any reason why you can't handle this. I bet you can. So, if I plug in a negative 5, negative 5 squared is positive 25. Then the negative in front of it kicks it back. Negative 5 squared is 25 minus 4 makes 21. So we have negative 25 21st. Oof, ugly. That's okay. Keep moving forward. Negative 4 squared is 16 with a negative in front. Negative 16. Negative 4 squared is 16 minus 4 is 12. I can reduce that one. 4 goes into 16 4 times. 4 goes into 12 3 times. That's easier to graph. I like that better. Negative 3 squared is 9 with the negative in front. Kicks it back negative. Negative 3 squared is 9 minus 4 makes 5. So we have negative 9/5, or negative 1.8. Negative 1 squared. Notice that I don't have the 2 because that's the vertical asymptote. Negative 1 squared is 1 with the negative kicking it back. Negative 1 squared is 1 minus 4 is 3. Positive 1/3. 0 over anything, in this case negative 4, is 0. And we already knew that because that was our root right there. 1 squared is 1 with the negative kicking it back, or kicking it to negative. 1 squared is 1 minus 4 makes negative 3. 3 squared is 9 with the negative in front. 3 squared is 9 minus 4 is 5. Are you seeing something? Are you seeing some symmetry? 4 squared is 16 with the negative. 4 squared is 16 minus 4 makes 12. And again, you're noticing, I'm hoping, all the symmetry that's here. 5 squared is 25 with the negative in front, making it negative. 25 minus 4 is 21. That's a 21. Let's plot them. Negative 5, oof, that's ugly. That's still a little bit over negative 1. Negative 5, a little past negative 1. Negative 4, comma, negative 4/3, negative 1 1/3. It's right about here. Negative 9 over 5. 5 goes into 9 one time with 4 extra, so we've got negative 1.8. So we're getting somewhere. Okay. In the middle, we have 1/3, 0, and 1/3. Like a little parabola, it's going to happen in the middle. And then the reflected, because of the symmetry, negative 9/5, so 3, negative 1.8. It's right there. 4, negative 1 1/3. It's right there. 5, oof, so barely off that thing. So connect from left to right. Mind the asymptotes. In the middle, when you connect from left to right, you are going to have a little parabola. That graph was terrible. Sheesh. That's not much better. Bounces off. Looks like it's going to do that. And then on the other side, shoot, there it goes. Best I can do it, y'all. It's hard to graph that small. Your horizontal asymptotes are your end behavior. So since your HA was at negative 1, both of those are at negative 1. Your y-intercept is already on the table. It happens to be also the same as your x-intercept, same ordered pair. Your domain, if I have room for this, negative infinity to the vertical asymptote of negative 2, union in the middle, negative 2 to 2, union on the other side of the asymptote. Range is going to be weirder because your range, both of the wings are symmetrical. They're the same thing. They're just reflected from each other. So your range is actually going to be both of these at the same time, negative infinity to the asymptote. That's taking care of both of them. And then here's something that's weird. Once you pass over the asymptote, you have a gap. You've got space right here that there's no graph. So your next graph picks up at 0. And we'll do 0 to infinity. Okay, negative infinity to the asymptote of negative 1, union, bracket, not parentheses, because you do in fact touch 0 to infinity. That is your range from low to high on the y. That's all the y's that are touched.